Welcome, science students, to today's lesson about unequal heating, the most basic reason for why we have weather. If you think about the last time that you were outside, you may recall the weather. Think about whether it was sunny or cloudy. And from your own personal experience, I bet you understand that the sun makes you feel warmer, while clouds or shadows make you feel cooler. This is because the energy from the sun heats you up when it shines on you, but does not heat you up as much when it does not shine on you. And this kind of goes back to that same idea that we learned about related to the seasons. When an area on Earth receives more intense sunlight, more direct sunlight shining directly on them, it ends up being warmer, that has more energy. And at those times, it also tends to be for longer amounts of the day, and we end up with summer seasons. When that area receives less intense sunlight and it's a shorter duration of the day, it's winter. But these same interactions occur and are responsible for our weather, just on a smaller scale than all of the northern hemisphere compared to all of the southern hemisphere. Before we can understand what's happening with the weather, we have to review a couple of key ideas that we've already covered. The first is this idea of thermal energy, which is heat energy. Earth gets all of its, or the vast majority of its, thermal energy from the sun. The sun transfers that as radiant heat, which is heat that travels by electromagnetic wave. So thermal energy is defined as heat energy, or energy that causes atoms and molecules to move faster, while radiant energy is that thermal energy that gets transferred by an electromagnetic wave. Just like one hemisphere might absorb more sunlight than another hemisphere, different materials absorb different amounts of radiant heat. Some materials are better at absorbing radiant heat and heat up in the sun much quicker than other objects. See if you can think of an example of two objects that absorb thermal energy differently. Maybe you've experienced where the concrete or asphalt heats up differently than the grass. Or maybe you've experienced a time at the beach where the sand heats up differently than the water. In these two examples, which one gets hotter? In the example of the asphalt and the asphalt gets hotter. In the example of the sand and the water at the beach, the sand gets hotter. Now I want you to think about the air around these objects that are hotter. Do you believe it gets hotter as well? The answer is yes. The air around a hot object gets hotter as well. And that's because those objects transfer some of that thermal energy to the air around it. This happens when air molecules bump into the molecules in the asphalt or in the sand. Those collisions transfer energy to the air. Just like if you would touch something that's hot, like the hot jar of water from our last lab, that heat gets transferred from the molecules in the glass into the molecules in your hand. When this happens, it's called conduction, which is a transfer of that thermal energy by direct contact. Just like some objects absorb radiant heat much quicker and easier than other objects, those objects that absorb heat very quickly tend to cool down very quickly as well and transfer that heat to another location much easier. If you think about the sand and the water, that sand heats up quicker than the water at the beach, and then the air gets the heat from the sand quicker than the air above the water. When air heats up, those molecules start to move faster and faster and faster, and they spread out and get further apart. This makes the air expand. it kind of swells. That makes it less dense, and less dense air will float above more dense air. You've probably heard the term that heat rises. That's because the air has more energy, it's moving faster and expanding away from other items. So far, we've seen three processes occur. We've had the sun radiate heat down to the earth through its electromagnetic waves. Those electromagnetic waves heat up the ground and the water and everything that we have on the surface of Earth. That ground heats up the air through conduction, and then the air starts to rise and expand, which is that first step in convection. Convection is something that you might be familiar with. After that air rises, it begins to cool down because it's farther away from that heat source. As that air cools down, the molecules combine, they get closer together and become more dense. That causes it to sink back down to the surface. And we end up with this cycle. And convection is a cycle. It's defined as the cycling of materials as hotter areas rise and cooler areas fall. And in this example, you can see this cycle as areas closer to that burner flame become hot, rise, they cool, condense, and fall. They heat, expand, and rise. They cool, condense, and fall. You might remember these convection currents from the study of plate tectonics. They occur within the mantle of the Earth and end up driving and moving the plates around the surface of the Earth. But just as that air starts to rise, we end up getting winds. And this happens because of a difference in pressure. Hotter air rises and expands. The molecules spread out, and they leave an empty void, some empty space, or more empty space than was there previously. This creates low pressure. There's less material, there's less matter pushing in on that area, so the pressure is lower. Because there's less pressure, there's less stuff there, other air wants to move into that empty area. And just on the opposite, colder air sinks and contracts, which makes it have higher pressure. As those molecules get closer and closer together, there is more and more pressure. As that more dense air bumps off of each other, it wants to spread out. And so we end up with wind. And winds blow from areas of high pressure to areas of low pressure. The molecules of air want to spread out when there is lots of pressure pushing on them, high pressure, and they want to go to areas where there is less pressure pushing on them, low pressure. You can always remember this by thinking of winds will blow from high to low. Here in this link, you can see that there are convection currents that form above this difference of land and sea. Here you can see the land is heated up more than the ocean, so this air is hot and rises. It expands and spreads out. This air is cooler, and so there's more pressure pushing down on this air here, and it blows inland, where it heats up, rises, cools, condenses, and falls. Later in the day, you'll see that the sun has set, and so there is less heat on the land compared to the water now. This land cooled off much quicker, and now this water warms up, warms the air above it, that rises and cycles. And so we get breezes coming from the land at night and coming from the ocean during the day. These same convection currents also occur at different places around the globe. The latitude can control the cycling. Take, for instance, these convection currents that occur They occur in different areas that have similar conditions. If you think about the equator, they've got intense sunlight just about all year round. They're directly in the sunlight pretty much all year. And so they've got very intense, very strong sunlight year round. The poles, on the other end, have very low intensity sunlight just about the entire year long. And then those mid latitudes, those areas between the poles and the equator, they've got a different amount depending on if you're talking about summer, spring, fall, or winter. They have times where there's very intense sunlight, and then there's times where there's very weak sunlight. And this creates convection currents in different areas of the Earth. For instance, in red, you can see the convection currents forming over the tropics. Those are very warm. They cycle very quickly. They cycle very, very fast. Compared to the areas above the middle latitudes, like you see above the United States there in blue, those ones cycle a little bit slower. And then up at the poles in white, you have more convection occurring above that North Pole, and it is moving a little bit slower. Because the equator gets more intense sunlight for longer periods than the middle latitudes, they heat up quicker, they cycle more, and you end up with these different speeds of cycles. This creates what's called the jet stream. A jet stream is kind of like a river of air that's flowing around the Earth. That jet stream is a narrow band that forms where these convection cycles are occurring. You can see that the subtropical jet stream forms in between the convection cycle of the tropical air and the temperate air. And the polar jet stream forms between the convection cycles of temperate air and polar air. That jet stream not only creates a river, but it helps to push along and move air from the surface around as it cycles. But if it stays put for several days, it starts to form an air mass. An air mass is a large area of air that has very similar characteristics. Here we can see some different examples of air masses and where they formed at. Air masses that form above a continent ends up being very dry. They're cycling, that convection, that heating, that cooling, that condensing, that warming, that expanding, that rising is all occurring over the surface of the land. And so it's very dry. There's just not much water there to evaporate up into that air mass. By contrast, we have the maritime or marine air mass, and those form over the ocean, where they are heating up and cooling down and heating up and cooling down, cycling above water. And that causes them to have a great deal of moisture or become very wet. We also have air masses that form at those different latitudes. Air masses that form up at the poles are very cool or cold air. Compared to air that forms in the tropics, those air masses are very warm or hot. These air masses are responsible for our weather. The way that they interact with different objects like another air mass or a geographic feature can affect our weather. Our next lesson will learn about how these different interactions create different types of weather. But today, it's important to remember a few key points. First, items on Earth heat up at different rates. Solar radiation or thermal energy from the sun heats up items at different rates. That's called radiant heat. Those items transfer heat to the air around them through conduction, and that heats up the air. The air then starts to cycle as it heats up, cools down, rises, falls. It creates a cycle that we call a convection cycle. That convection cycles create jet streams which can move air around the Earth. Thank you for your time Have a great day.